Assalamualaikum warahmatullahi wabarakatuh. Uh, my group will present for our project for subject EMM 3513 Thermodynamic 2 for project study of renewable thermal energy power for sustainable future, which is we will touch topic about biomass rice husk. I will introduce first my group mate. First myself, Muhammad Arif Najmi bin Zulkifli 2190141. And my group mate Nur Pegawai Cadet Uzwatun Hasanah binti Idham Khalid 2190129, Muhammad Syahmi bin Muhammad Asri 2190761, and Muhammad Akmal Syafi bin Muhammad Syamsul 2190088. So my friend will continue the presentation.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. I am Muhammad Akmal Syafi bin Muhammad Syamsul. I will start with introduction of biomass. Our earth is filled with a variety of plants, whether wild or cultivated. These plants are a storehouse for solar energy and chemicals. The source of these plants that come either from land or ocean is called biomass. Biomass is considered a renewable resource because carbon dioxide from the sky and water from the ground mix during photosynthesis to form carbohydrates, which are the fundamental building block of biomass. When biomass is efficiently burned, oxygen from the atmosphere combines with the carbon in the biomass, resulting in carbon dioxide and water to create new biomass. Okay, next I will talk about rice husk as biomass fuel. Okay, first, Myanmar was the first country to use rice as an energy source in 1889. The United Nations Food and Agriculture Organization (UNFAO) predicted that rice husk would become a key fuel resource in the near future in 1971. The most successful and lucrative renewable energy source is now accessible when rice husk burn properly. Rice husk-based power plants have the potential to be both lucrative and environmentally friendly. Okay, next, I will talk about characteristics of rice husk for combustion. Rice husk has a better chemical composition than many other biomass fuels because rice husk has a low corrosion, fouling, and sintering rate. Due to the exceptional ash composition, it gives a very high ash melting temperature, about 1500 degrees Celsius, for the rice husk, which means that rice husk is essentially unaffected by fouling, sintering, and slagging during reactions in the combustion chamber and on boiler tubes.
Present about working concept for rice husk. From the rice husk, we will do a pre-treatment to reduce a size, desiccation, and torrefaction. Then we will processing to combustion, gasification, and pyrolysis to make a product of heat, gas, and liquid fuel. Then it will transform to heat energy, electricity power, syngas, and biofuel. Then I will explain about rice husk to form a fuel. The following is a summary of the characteristics of rice husk compared with other solid fuel in terms of energy uses. Its high silica content causes the wearing of the component in process machines such as a chopper and grinder. Content of volatile matter in rice husk is higher than in wood and much higher than in coal, whereas fixed carbon is much lower than in coal, as content in rice husk is much higher than in wood and coal, which cause barriers of energy conversion. It high content of ash, alkali, and potassium cause agglomeration, falling, and melting in component of combustors of boilers. Available solution to resolve barriers in energy conversion from rice husk is pre-treatment. Rice husk could be prepared through mechanical, physical, and chemical means that a true bioprocess or a combination of this process to increase efficiency. Available solution to solve barriers in energy conversion from rice husk is pre-treatment. Rice husk could be prepared through mechanical, physical, and chemical means a true bioprocess or a combination of this process to increase efficiency. In further energy conversion, these pre-treatment technologies can be referred in the class Baker and Sadaka and Nagy. Other solutions for ash-related problems in rice husk are to combine it with other fuels that are lower in alkali and chlorine, to reduce the temperature in combustion system, and to use other type of conversion system such as organic Rankine cycle and two-stage combustion. I will continue the presentation about rice husk to form electricity energy. Procedure of electricity generation from rice husk. There are several methods of generating electricity from rice husk. Among some effective ways, here power generation by rice husk gasification is adapted and the system is designed in such a greener way so that the system involves absolutely zero emission. After preserving there, the rice husk is conveyed to the gasifier where it goes through some certain chemical reaction to produce syngas. There are a few of types gasification are present in the market which have different sets of pros and cons such as fixed bed updraft and downdraft. However, the cheapest among this gasification is downdraft gasification, and this gasification chamber produces a product gas with very low tar content. So for utilizing this benefit for small scale rice husk biomass plant fixed bed downdraft gasification is ideal. Here biomass fuel is feed at the top of the reactor or gasification. Then, as the fuel moves downward, it reacts with air. The suction of a blower or an engine supplies the air needed for the reaction, and then the air is converted into a combustion, produce a gas through complex series of reactions. A downdraft gasifier is a chamber in which both the gas and the solids flow in the same downward direction. Due to downward flow, this type of gasification produces cleaner gas than any other method like updraft gasification chamber. It is because in the downdraft gasification, all the produced tar is secondary, whereas updraft gasification produces primary tar. Moreover, the downdraft nature also allows the greater conversion rates as gravity force the matter flow through the gasification chamber. It has some limitation and controllability for large diameter power output. Due to the formation of preparation channel being at the fuel bed, it preserves the tar-rich steam to move from the pyrolysis region to enter the combustion region. By using slow rotation pedals, uniform distribution of particles in the bed is provided, and thus this problem is extinguished. The action involved in the full process are drying, pyrolysis, also known as devolization, and combustion, also known as gasification. In the drying process, the rice husk is dried at high temperature, which results steam, while the char and volatile products react with carbon dioxide and small amount of carbon monoxide. Then again, the carbon from char and steam react and produce carbon monoxide and hydrogen. As this reaction is reversible, after a certain time, the amount of carbon, steam, carbon monoxide, and hydrogen become equal, and the reaction equilibrium condition. And this final reaction increase their residence time of a reaction gas and organic materials as well as heat and pressure. There is an ash pit where the ash pit of rice is accumulated and is ready for disposal. To make the purification system more environmentally friendly, so an extra water purification system is necessary for this kind of units. To eliminate these barriers, this exclusive dry gas purification unit is introduced. This system excludes all the limitation of the wet type purification unit. The maintenance needed of this type of purification system is minimal as there is no slug production is present and this efficiency maximum. Below is the specification of purified gas from the system. This is the unit's power generation section of the system. Here, the syngas collected from the purification system is used to generate electricity. Here, two types of turbine can be used, gas turbine or steam turbine. The turbine shaft is connected with generator which which generated electricity while the turbine rotates.
Okay, next. Today, technology progress has successfully built several rice husk power plants in several developing countries. This step taken by these countries is wise and beneficial to the world, people, the economy, and the environment especially. Among the power plants that already exist in the world and are close to us are: first, power plant in province of Isabela in Luzon, Philippines; second, power plant in province of Pichit in Thailand; and power plant in province of Sri Sangda at Roy at Thailand.
Today I want to present about a typical power plant functioning in a village of 5 million watts rice husk power plant design. So the rice husk power plant come from the field and then go to husk power plant, which is on the husk power plant. It can generate electricity, and the electricity then supply to small enterprise, which is at the rural electrification on the small village. So next, this is the method that we are using, which is either a Rankine cycle. So the first one we have the pump, second is the boiler, three the turbine, and four which is the condenser. Next, this is how the process in either Rankine cycle work, which is the first one, pump supplies water into boiler with high pressure, then water is heated inside the boiler. Then rice husks are acting as a fuel to heat the water and become superheated steam and sent into the turbine. Then the cycle starts again to drop and go into the condenser from steam to turn into water and into pulp. Next, we go to the example of calculation, which is there are 4 states in the either Rankine cycle, which is state 1, state 2, state 3, and 4. So the first one, we have to assume the calculation, which is no kinetic and potential energy transfer. The steam is superheated and high temperature, and condenser are to regulation condition. On calculation, which is P1 equal to P4, P2 equal to P3, and 5 megawatt output. This is the example of calculation. So state 1, P1 equal to 10 kilopascal. So from the 10 kilopascal, we can refer to the table and get the T1, S1, S1, and V1. So next, from the data that we get, we can calculate the Win, which is V1, P2 minus P1. So we get 7.06 kilojoule per kilogram. And from the Win, we can calculate the H2S, which is 198.87 kilojoule per kilogram. So next we go to the state 2, which is compressed liquid. So from P2, which is 7 megapascal, we can get the NP, H2A, and we can calculate the Win, which is 0.07 kilojoule per kilogram. Okay, next is state 3, which is superheated. So when we get the superheated, we can refer to the table A sheet, which is we get the data P3 equal to 7 megapascal. No, P3 is the data given, which is 7 megapascal. Then we get the T3 500 Celsius, S3 and S3. So next we go to the state 4, which is P4 equal to 10 kilopascal and S3 equal to S4S. So X we need to find. So from the S4 to SF plus X SFG, we get the X value, which is 0.8202, and then we can calculate to the next step, which is S4S, which is 2153.81 kJ per kilogram. So next, when we get the data for state, we can find the W out, W actual, Q in, Q, and efficiency, thermal efficiency, which is 3212.52, and we get V out, which is 1131.83 kilojoule per kilogram. V actual we get 1131.76 kilojoule per kilogram, and Q in we get 3212.52 kilojoule per kilogram.
Okay, so now we go to conclusion for our project investigation of rice husk. So, first, the development of technology today has greatly helped human beings in meeting their needs, especially in generating alternative energy. Technological advances have resulted in various thermal energy generation processes based on renewables such as solar power, biomass, biofuel, wave energy, wind energy, and many more. The project will be focused on biomass, which is rice husk. For the investigation and study, the rice husk gives two products of energy, which is electricity and fuel for engine, commonly used in combustion boiler and steam turbine system. The electricity gained from the combustion of the rice husk to heat the water and produce water vapor to rotate the turbine and give electricity power, while the product of fuel obtained through a fuel process from the rice husk biomass gasifier power system. Based on data obtained and research, Malaysia have a good potential to have biomass renewable energy using rice husk. It is because Malaysia is one of the largest rice producer in Asia and the world. So the production of the rice husk is also widely obtained. Unfor- Unfortunately, the problem of lack of cost and careless planning by the developer caused it to fail to be realized. However, the surplus rice husk is in Malaysia is not waste, but used as other used products such as fertilizer, animal feed, and others. Effort to develop this biomass power generator are likely to be successful in the next few years as the need for the energy power is increasing every year. That's all from us. Thank you.